elbow
You
yesterday.
you hit your.
The funny
Bumped it, yeah.
Funny
Yeah,
bone?
I didn't even hit it that hard, but when you hit it, it goes down your whole arm, and you're like, ah.
Okay, so.
No, it's just
Be quiet and listen.
Sorry.
So, when we started talking about the area of polygons, regular polygons that are inscribed, regular, there we go, polygons, inscribed in a circle, we came up with the formula that the area of the polygon, that's right, polygon, is equal to mr squared. Okay, so that m is that special case where we just use the number of sides. So m is equal to n times the cosine of 180 divided by n times the sine of 180 divided by n. So we came up with this formula, okay? So we're gonna show you how, just like we did yesterday, that if we go bigger and bigger and bigger and bigger, how m comes closer and closer and closer to pi. Okay, so let's make that chart again. Okay, and this time, I don't really care because I'll show it to you later. This time we are just gonna find what m is for each case. This is going to be the number of sides, but we're going to start a little higher so we don't have to get it up quite as much. So we're going to start at 360. Then we're going to go to 720. Then I'll go to 1440. Then I'm going to jump to 10,000. Good morning. Then we're going to jump to 100,000. And we have 1, 2, 3, 4, 5, 6. Okay, or 5, and then we'll go to 1 million. Okay, so we're going to start this side. So Elijah, you are calculating m. You're going to use this as 360. So the number of sides you're going to put in for m is 360. Okay, so in your calculator, find that. Okay, Paxton, 720 this time.
Remember last time?
I do remember last
We don't want to
Harrison, you're doing 1440. Okay, Micah, let's have you do 10,000. Okay, Luke, you're doing 100,000. Okay, so you're calculating this one. And Aaron, you are going to do 1 million. Okay.
Good luck.
Good luck. It's not that much harder, he just has to type the number in. So, calculate those figures.
I gotta grab my calculator for this.
That would be a good idea. I'll just tell you, this is not something you can do by hand. You have to use your calculator.
Mike has like pages of just numbers.
Yeah, can you imagine the people that actually went through and did this? They didn't have calculators. Like we were talking yesterday, they were kind of bored, I think. Because when your right mind would sit there and calculate these, I have no idea. But anyway.
Probably too much tax money or something.
Yeah. Huh? That's true. I don't know. Well, several people are writing things down. Looks like Harrison's got his done too. give you another minute or two to finish this up. So what we're trying to show basically is that a circle has infinite number of sides.
Right stuff.
Okay, Elijah, what did you get for yours? What was your answer for the M? Okay, need to finish that one. Aaron, I know you have yours. What is your answer?
3.141592.
Unless you type it all out, or unless you type it all out. And then type it all back.
Okay, thank you. Luke, what's yours?
It's like really, I got 3.159265152.
2651.
26515.
Okay, I'll just stop there because we can compare it to his, okay? Micah, what'd you get for yours?
I'm still doing.
Okay, Harrison, what'd you get for yours?
3.14158.
Wait, 3.14158 exactly?
822685.
Wait, 82625.
85.
Okay. Paxton, do you have yours?
3.141552779.
Okay. What are we doing, Micah? Getting it?
I'm not sure if I'm doing it.
Did you get yours, Elijah? What'd you get?
3.1424572.
I'm getting the wrong one.
Okay. Just waiting for Micah. Did you get 3.14 something?
No, I'm not sure. I feel like I'm doing something wrong because
Okay.
I got like 9 points.
Yeah, did you write down the right formula?
So take the cosine and take
Right.
180, divide it by n.
Okay, so that's divided by 10,000.
Yes,
And that,
that's your angle. So now you're taking the cosine of that angle. That's how small the angles are inside your,
so should I not do it in all on a cosine? Will that mess it up?
no, so do cosine.
Okay.
Then say times sine of that same number,
Wait, times, oh,
because it's cosine of that number times sine of that number, and then you
Okay.
multiply the answer by 10,000.
okay, so cosine of what, 180 divided by 10?
Correct. And then put a parenthesis after that,
Oh, okay,
and then put times sine.
times, okay.
And then put parentheses after that, after you get the 180 divided by 10. And then multiply it by 10,000.
Locked.
Yeah, okay, that's right.
So what'd you get?
3.1419247.
Oh, that's wrong. That's not
I know.
high.
Okay, so
Try
let's
again.
just look at this. You can see, and then our formula is basically mr squared. But this number here, as we get larger and larger, number of sides is getting closer and closer to pi. Okay, pi is actually this number. It's a little bit less than this. 14159 and I think it's 5265. 265. Look at this. It's not much difference. 36. We are almost at pi at 1,000,000. Okay, at least that many out. okay? We are out, so when you get to 1,000,000, you are very close to that many decimals being accurate for pi, okay? And so that's where we come up with area is equal to pi r squared, because if you notice, the number of polygons, this number, which is the area of a polygon, is coming closer and closer to pi. So we just say, okay, then a circle which has infinite number of sides, okay, we can't put in the number of sides because it's infinitely many sides, okay? So as n gets bigger, the m gets closer to pi, so therefore, this formula for area of a circle comes from looking at this. And again, when they do this, they come out with that same number that they did when they did the perimeters, okay? So they see both of those when they were working with this, they saw both of those, okay? So that's how you can see that just by this basis, the area of a circle is pi r squared. Because as we increase the number of sides, which a circle has infinite, it gets closer and closer to the number of pi. Now, we can't use the exact number of pi because even your calculator doesn't probably carry that many decimals. I'll just be honest. It probably doesn't have, but obviously doesn't have pi in there accurately because you can't end it. And you can't, doesn't start repeating, so it obviously is not in your calculator correctly. Depending on your calculator, it probably has different amounts of decimals in the pi button. So when you hit pi button, it probably depends on what they put in as far as accuracy. How many decimals out does it go? I don't know, okay?
If you hit pi equals on these ones, it goes out 9.
It goes out 9, but it may be further in there
Mm-hmm.
in your calculator when you hit the pi button.
Yeah.
That's all you can see
That's
because
all
of
you
the
can see.
display.
But it
Okay.
won't let you go over either.
No, I know that. What I'm saying is, that's what you can see on display. And yours, that calculator would never probably put it
Yeah.
on farther, just because that's a pretty cheap calculator.
Mm.
If you get to a more expensive calculator, you might be able to see it go farther. So it really depends. So what I'm saying is different calculators probably have different lengths of pi in them, depending on how they were programmed. Okay, so you never have exactly pi. So basically that's everything about 14.5. It's just showing you what the area of a circle is. It's showing how it came from that area of a regular polygon formula, and that's what that whole thing is about, okay? So let's go to 14.6. Does everybody have this down? I'm gonna make sure everybody has it down before we go on. I don't see it all written down on Paxton's paper or Harrison's.
What?
You don't have the whole thing written down.
Not everyone's.
Why not?
I just got here.
That's true. You got yours written down. Good job. You have you guys just written?
I just got here.
What do you mean you just got here? You helped calculate that.
Wrote mine down.
Yeah, you did write yours down. Okay, let's write them down, guys.
Thank you, Uncle. Honestly, wouldn't have written this.
I don't want to.
Yeah, it's like,
That's why I'm not writing them.
I get 20 here.
360.
I get what you
I'm just gonna do one of them. You just write the numbers. You have like very important brain.
Hey,
It takes me too much brain power.
It's more dangerous to have a pen.
Can't go back.
There's no way.
Jason's like, there's no going.
How the fuck switching from
What? How does 720 make it? How does it make it?
What?
less. It didn't, goes from 3.14.2 to 3.14.1, or is it, or am I just kind of tripping? Oh, that is weird.
Well, it's supposed to be 3.1.
Oh wait, yeah,
Yeah.
360 is inaccurate, it's too big. It's not necessarily right.
It's because that's got all those sides.
Oh, it's so weird.
The sides are more
It's
pronounced.
calculated, yeah, it's confused.
It's if you have a bunch of little sides.
So how do you do cosine and sine without a calculator? I shouldn't ask.
Yeah, don't ask.
So, what? Do you read?
We don't talk about that here.
Wish. We can always look it up.
Let that
at
wait
the
till
YouTube
next
video
year,
later.
A 5-hour YouTube video.
Seriously, that'll work.
Just make sure you don't look for a tutorial.
You just see
You
someone
just look if
graphing
it's
under
possible.
the
Now they did. Kind of.
I bet very passing for the video.
Maps.
This is how you calculate.
You ever watch V-Size?
That sounds.
He's funny though. He does kind of scientific, it's me, just like really weird.
Okay, let's go ahead and go on. Hopefully most of you've gotten those written down. If not, you can copy them from someone else that did get them all written down. Okay, so later in class you can copy them. This is probably the more important stuff is the tough stuff at the top that's written. Okay, so Jake, I'm gonna let you copy from somebody else. Okay, Harrison also. Okay, so we're gonna go on to 14.6. And this is talking about a sector of a circle. We haven't defined a sector yet, so we have to first define a sector. And then we're going to talk about how you find the area and the perimeter of that sector. Okay? So let's start with a sector of a circle. A sector of a circle is the arc, the intercepted arc of two radii. Okay. So basically, it starts, the sector will always be in the center, okay? The sector will always be in the center, okay? So a sector is you just take any two radii, and this is called the sector, okay? You could also call this the sector, that's the major sector, this is your minor sector, okay? But it's always, these are radii, and so what you have is this, it's a curved cone kind of like shape when you're looking at a sector. Okay, so the sector, it is where two radii intercept an arc, and that is called a sector of the circle. Okay. Can somebody tell me, do we know what M is?
Is it the midpoint?
Oh, it's M degrees,
Oh.
okay? So M degrees is going to be whatever portion of the 360, right? It's a portion of the 360 degrees that you go around, because this angle is at the center, and we know in the center going completely around is 360 degrees. So the portion of this, of the circle, so the M degrees is going to always equal, well, not the M degrees, let's do this. How do I want to say this? 360 degrees, M degrees divided by 360 degrees will be the measurement of the arc. No, that's not true either. It's the portion of the circle, that's it. It's the portion of the circle of the sector. That the sector is. Okay, so basically, we can figure out, if we can figure out the area of the circle, if we can figure out the perimeter of the circle, we can figure out all of the sector's area and circumference too, because it's just a proportion. Whatever the degrees of that is going to be the amount of the circle that it is. Okay. So if you're looking at this, what you can do is the area of a circle here, or the area of a sector, is basically what we're saying is a sector's area is a fraction of m degrees over 360 degrees of the circle's area. Okay, we know that the sector's circumference, which really is just the length of the arc, is a fraction m degrees over 360 degrees of the circle's circumference. Okay, so it's really pretty easy, okay? If I give you that m is 60 degrees, okay? We're just telling you that right now I'm making m 60 degrees, okay? Well, if you look at what portion of the circle is that, 60 divided by 360 is 1/6, correct? That sector is 1/6 of the entire circle, because 60 out of 360 is 1/6. So if I find, I don't have the radius right now, if I gave you the radius equals 4, as long as I have the radius, I can do this. I can find the area of that sector, because it will be 1/6 times pi r squared, because this is the area of the circle. This is your portion. Okay, so we can put 4 in there. Okay, so we get 1/6 pi times 16. So reduce this and it becomes 8/3 pi. So the area of that circle is going to be 8/3 pi. Hopefully all you can follow that I reduced that by 2.
2 and 2.
So it's really pretty easy. Okay, the main thing is you have to find out what section or what fraction it is. Okay, so we also know the circumference of it will be 1/6 of the 2 pi r, because remember this is the area of not the area, the circumference of the circle. So in this case, we'll replace r with 4. So I get 8 pi times 1/6. I get 4/3 pi as the circumference. Okay. If I knew that the radius was in inches, what type of unit would be on the area? The radius is inches. It'd be squared inches, inches squared. Because notice we squared the 4, so we also squared the inches. So it's inches squared. So if I say that 4 is in inches, what is the unit on this, the perimeter? Not the perimeter, well, it's kind of like the perimeter, it's the circumference or the length of the arc. What would it be in?
Wouldn't it just be inches?
It would just be inches, because that's just a length measurement. We didn't square the 4, we didn't do anything to the 4, we just multiplied it by it. No, it's not cubed, that's when we get into spheres.
Harris.
No, there's
No.
unlocked. We got a sneak peek.
Okay, so that's basically what these two sections are about. So we're gonna do a couple up at the board so that we can get used to them, and then we'll take a break, and then you can work on your homework, so hopefully people will get caught up. Okay? Yeah.